All right, so a couple things off the top. I dropped a couple papers that we'll kind of look at today. You don't have to necessarily have them open. I'll have them open up on the screen. I just kind of point out what I want to from them in terms of kind of where we're at, kind of ending the class. So that fifth homework assignment, you can turn it in as late as Monday. That's technically the last day of classes. If you'd like to turn it in earlier, that would be great. I can kind of start getting those graded as I see them turned in. For your project submission, so it looks like it's out at 95 points. That's because the proposal makes up the other 5. So once I get those graded, I'll kind of post like a complete project grade where I add your points from the proposal to kind of your points from that submission. I think I mentioned last week, so we'll go over some material today and then kind of end a little early. And if you guys have any questions over what you're working on, I can kind of try to use it almost like open office hours in here. We'll kind of hang around and I can answer any questions for those of you who are here that you have in your projects. I will not be around on Friday. So if you want help kind of this week with those, I guess try to meet with me tomorrow or on Thursday. If my office hours don't work, send me an email. We can find another time. Otherwise, that can be submitted as late as Monday at the end of the day as well. Okay. And then Thursday, so where's that? I'll kind of walk through or I'll work through some of these problems that are on this final exam practice solutions. Also try to get up another set of questions sometime tomorrow afternoon, just so you have additional things to look at and kind of problems to work through. You've got these solutions here. I also put up the 4th homework answer, like the answer key there. So that's a good thing to kind of look at as you're studying for the final. That 5th homework, if you turn it in or kind of curious about what the answers are, obviously I can't post the answer keys until after Monday. So you'd only have kind of 2-3 days with that answer key. But if you're curious, you already turned it in and you want to stop by and kind of, well, what would this complete, what I have looks right, or what would a full correct answer be? You can kind of stop by my office hours before that due date and I can kind of walk through that with you as well. Okay. So when we do that kind of more exam review on Thursday, I'll mention a little more specifics about the exam. It'll probably be a combination of some multiple choice as well as some short answer, kind of like the midterm was. Those 2 homeworks, homework 3 and homework 4 would be good ones to review, look at the answer keys there. Obviously, once we have that 5th one after on Monday next week, and then that set of final exam questions, all would be kind of good material to study for that exam. Today, what we'll be doing, the exam, unlike the midterm, the final might have a little bit of more linear regression stuff. So primarily, it won't be as much interpreting kind of output or looking at regression output, interpreting that, but more so thinking about what variables could I use to estimate a relationship, maybe state, I might leave it very open-ended, kind of like some of those questions on the 5th homework. If you take a look at that, those make some good representative questions about the linear kind of regression or kind of questions related more so to the papers that we've looked at. And we'll be going through a bunch of papers today, and I'll kind of point out things that I would want you to know or what we'll be able to do using the variables or for the linear regression. So that's kind of where we're at in terms of ending kind of this class. And so any questions for me before we can jump into the last of the material here today? Okay. I will put up one last online quiz today too that's due before we start class Thursday. It's going to be preference-based, so you should all be getting 10 out of 10 as long as you get on and get that done. Kind of give me a little direction. I'd appreciate it for things. Some of the questions will be related to things that maybe I've had ideas of doing things differently in the course and kind of trying to get some preference-based stuff from you guys so you'll help the next class. So I won't jump quite in the slides yet because I want to try to keep these topics together. So I put up this WNBA, I think they called it racism. WNBA racism file on Canvas. You've got to scroll way down because it's a bunch of different papers. So this is kind of interesting. I showed you how to use Google Scholar, but you can search for a very broad topic, or you can search like a specific journal. So here I searched this journal, Sport Finance, and it's just a collection of different papers that they've published. So a bunch of different ones. So where was that? 70. Let's make sure I'm on the right paper. So here we go. There we go. So this is the one that we're going to take a look at. If we scroll down here, their main idea is whether or not there's racism that's existing on some dimension in women's basketball. And so they go through some pay stuff that's not, I don't think, overly interesting. But I think what is kind of interesting here is the way in which they're trying to identify racism. So they've got this dependent variable, and they abbreviate everything, and you got to hunt through the paper to figure out what it is. But MGM here is kind of the minutes per game, right? They have different productivity measures of the players, right? These are things like points scored, rebounds prior to the game. They've got their height. They've got the number of games they've played in the season. And then, a bunch of other things. Then they come down here and they're going to look at this indicator variable for whether or not this was a non-white player, right? So that coefficient should tell us, well, when this is a non-white player relative to a white player, right? That would be the one group relative to the zero group. Then the expected change in the minutes per game played would be whatever beta 7 is here, whatever that coefficient, that slope coefficient is. They then include the same thing for kind of maybe there's a difference in kind of white versus non-white coaches in the minutes they play, even on average, every player. And then they include this interaction term, right? So this is where their kind of intrigue is, which is here, take that non-white player variable, multiply it by the non-white coach variable. So the only situations where this is going to be a 1 is if both of these variables are 1. So you'd have to have a non-white player and a non-white coach, right? And does that change the predicted minutes played per game? Right? So are non-white coaches playing non-white players more or less? So that's going to be kind of an evidence of potential, like, forget what they call it, like own race preference, which is, I guess, a nice way of maybe defining discrimination. So that's going to be evidence of kind of like a preference for own race. And then here, this non-white player, well, that's going to be, that coefficient is going to represent all kind of white coaches, the change in the number of minutes played by non-white players. So that will help us identify, is there some discrimination going on towards other races? So this beta 7 will tell us the effect that, white coaches, what's the change in the minutes played per game for non-white players. And then this beta 9 will identify, is there any own race preference? So the additional or fewer minutes that non-white players are played by non-white coaches. So those are going to be the two coefficients that we really focus on. They do some things here that we're not going to worry about. We'll scroll down to the regression output. And they ran 3 different models. So they ran one where we use what we call these fixed effects. So this was just indicator variables, right? So for every single player, they included another variable that was a 1 if the observation was from that player and a 0 if not. So this should hopefully capture anything that was specific to that player that we couldn't measure or we didn't have data on. They did a similar thing, and here they didn't include player fixed effects, but they included team fixed effects, right? So this was just a 1 if they were on the I don't even know, something stars, I think is an WNBA team, right? And so it'd be a 1 if they played on that team, 0 if not. And then they included this one in the middle where they used both of those, right? They had team and player fixed effects. So all just slightly different models. There is some issues that outside the scope of this class with running player fixed effects. And so they wanted to kind of have one with it, one without it, and then one where they included both. So if we look up here, not surprisingly, right? If we looked at that coefficient on points scored, it's very significant, right? 2, 3 stars, and it's positive. If a player scores more points on average, they're more likely to play a higher number of minutes, right? That's not surprising. So we're going to go down here. Here's all those control variables. And we're going to look at first this non-white player, right? This is kind of that indicator for was it a non-white player. And we see here that there's kind of this positive effect, right? Now, when they only included team fixed effects, looks like that kind of coefficient goes to 0. and it's no longer statistically significant. So we can't reject the null, which, remember what we've said before, we always start out assuming in these regressions, we're assuming that these slope coefficients, or the relationship between the x and the y variable, doesn't exist, right? And then if we can reject that with a low enough p-value, we're essentially saying we're rejecting that there's no relationship, or we found evidence that there is, right? And so that's what those stars were indicating to us. So looks like maybe there's white coaches are playing non-white players at slightly higher minutes. If we then look at this interaction term, so our non-white players who have non-white coaches played fewer or more minutes. And here we see, at least from two of the models, and even though this significance goes away, it's still negative, that actually there's not a same race preference, there's actually a same race almost discrimination. That when I have non-white coaches, they actually, holding everything else constant, so the thought experiment is two players with the same number of points, same number of rebounds, same height, same age, all this stuff, but one of them, and they both play for a non-white coach, but one of them is not white and one of them is, the non-white player actually gets played a fewer number of minutes per game. So this is some evidence that there's actually not discrimination going on across race, but actually within, right? That there's actually maybe, and who knows what's driving this in terms of human behavior, but maybe it's coaches are worried about images, or maybe this is a mandate coming down from the top, right? So maybe this is up at the ownership level. It's hard to say, but we do have evidence that for non-white players, when they have a non-white coach, they're actually played a fewer number of minutes per game. But that for white coaches, right, the non-white player is actually getting played a higher number of minutes per game. So kind of an odd kind of finding here, which is probably why this got published, because it's not something that you necessarily expect. So I wanted to kind of bring this example into class, or look at this paper, because we are able to estimate using linear regression some pretty important, or answer some pretty important questions, right? And so here, this is one in which we can identify, is there some type of behavioral differences or treating players of different races differently? And we're finding significance here. So we do have some evidence, that maybe we should be concerned with there is slightly differential treatment towards different groups here, different players. Okay. Now, I already have the exam written, so I'm not going to push you as far in the exam to give you these interaction terms, but they are very interesting. So one thing for your projects, I think I've suggested to a couple of you to do, because we haven't really spent enough time and we're not really going through these interaction term examples in super detail. So another way that you can get at this is maybe I just separate my data out so that I have all of my white players, all of my non-white players, and then I could run two separate regressions. And then I just have to include one indicator variable, which was the coach non-white. And then I can see, does that coefficient look differently in the regression that I ran for white players than the regression that I ran for non-white players? That's another way of identifying whether or not we have kind of different groups being treated differently, right? So you can do this in any any context, any example, any sport, right? You could kind of identify, is there some type of discrimination going, at least in terms of the minutes the player is able to be played per game. And the reason why that's so powerful is because with sports, we have all this data, right? So I can really control for, this is basically otherwise, a player scoring the same number of points, same number of rebounds, same height, same age. You can compare this thought experiment of two otherwise identical players, but the only thing different there is either their race or the coach's race, right? So it becomes a pretty powerful statement. Okay. Any questions here before we keep moving? All right, so the last kind of topic that I think is somewhat interesting, and there's some newer papers out there, and this one I think is pretty interesting, is something that we kind of call peer effects in economics. So peer effects is the idea that if your peer group is engaging in a certain behavior, you're more likely to engage in that behavior as well, right? So I always tell the example, I knew this couple and they had a daughter, and she told them she couldn't see things at school and she needed glasses, and they take her to the eye doctor and they're like, yeah, she has 20/20 vision. Eventually they get it out of her, 3 of her friends had gotten glasses in the last month, and she wanted to also have glasses, right? So this is the idea. If your peer group is doing something, or you're experiencing something, you also are more likely to want to experience that. So the question is, right, in this paper that I pulled some stuff from, is did Jose Canseco have an effect on his teammates, right? So he is one of the most well-known kind of steroid users in baseball. There's also a lot of stories that he got other players steroids. And so do we see players that after they played with Jose Canseco, did their performance actually increase? Now, we can't say for sure that that's because they then were more likely to use steroids, but that's the idea, right? Why else would there, I guess the story could be that he was so good at baseball that he taught them something that made them a better player. But the idea is it's likely that it was being driven off of kind of steroid use. So they had a lot of data, right? 39 years of annual performance data for every single player. They then estimated this equation, right? So they have this performance of the player, and they use different measures. I think they use like batting average, they use the number of home runs. So they had all these different statistics that they could use for their dependent variable. So we'll just look at multiple regressions where the dependent variable is a little bit different. Sometimes it's batting average, sometimes it's home runs. And then they included a bunch of player controls. They don't list them all here. They then had kind of this variable that was a 1. If the player was playing currently in that year playing with Jose Canseco, a 0 if not. And then they had another variable that measured, okay, was this a year in which was after they played with Jose Canseco, a 0 if not. So for a lot of players, these are going to be zeros because they were never currently playing with Jose Canseco. And if they never were playing with them currently, then there was no way for them to ever be playing after they played with him, right? And so this should tell us probably this beta 2 is more reliable, that, this is definitely after he would have had the opportunity to introduce them to, steroid supply or kind of how to use steroids. We may find a positive effect here if, in the current year, we don't know exactly when, maybe, they started using after they began playing with him. And so we may not see this be quite as large of an effect, right? The kind of concurrent playing with Jose Canseco. So they run this regression. And before we even look at the output, just kind of looking at the average is interesting to look at. If we just looked at the average number of home runs, and then they kind of looked at a shorter time frame, kind of when they believe that the steroid use was at its height, players who hadn't ever played with Jose Canseco, their average home runs was just below 11. Those who were currently playing with them was at 13, and those who were in a year after playing with Canseco are at 15.6, right? So just the averages look like maybe there was something going on. But we're not controlling for anything here, so we want to make sure we have all those additional controls, run an actual regression. And you kind of see here, here's that coefficient. This kind of row represents the coefficient from the regression of the current year playing with Canseco. Here represents that coefficient after playing with them. And then they just kind of tell you, in all of these regressions we had, and you can look at the additional controls are listed down here. So years in the league, manager's lifetime winning percentage, what the ballpark's kind of hitting factor was. So they looked at kind of control for the average number of home runs hit or the average strikeouts in certain ballparks. They also included a dummy variable for, was it American or National League. They also included this idea of player fixed effects, right? So kind of capturing anything that they weren't able to measure about a player with those fixed effects. And you kind of see here, when it comes to home runs, there wasn't really any effect of currently being in that first year playing with Canseco. But after that first year, huge positive coefficient and significant at the 2 stars is what, 5% level, or with 95% confidence, we could say there was a relationship between being in a year after playing with Jose Canseco and the number of home runs a player was hitting. What's also interesting, so you see RBIs also went up, batting average went up a little bit. Looks like a small effect, but batting averages are generally between 150 or 0.150 and 0.4 would be an amazing one. So we'll see smaller changes there. But the interesting one is also there's a huge increase in the number of strikeouts, right? So maybe, like I said, the authors kind of give into this, that maybe this was a result of steroids, or maybe it was they saw the way he batted and altered their approach, right? That is a possibility. But if we're going to be betting on which of those is probably true, I would probably take the latter. And the reason why is because not only did they see that there was an increase in performance for batters, let's skip a little bit here. I thought I had it. Oh, did I not grab it? Oh, I forgot to grab that table. Well, what they also found was they ran this for pitchers and found some pitchers had increased performance as well. So it's a little bit less likely that it was that they were changing their approach. They also like specifically looked at what they considered power hitters, and I believe the way they identified this was they set some thresholds for the number of home runs, and what they found was for those power hitters, the effect was even larger. It was like 0.9 before, now it's 1.9. The strikeouts went from 3.1 to 5.7 higher. RBIs was also a higher coefficient. And they also found that the players were more likely to get walked, right? So some evidence that potentially there was some type of peer effect from playing with Jose Canseco here. They then looked at things that they thought might be less, we call these kind of counterfactuals in economics. So it's when you run a regression for something where you would not expect there to be an effect from the variable that you're looking at. So if I'm looking at steals or fielding percentage, there's not as much reason to believe that steroids would affect those performance measures. And sure enough, they don't find any significance in kind of those steals, fielding percentage or errors. They find positive effects on at-bats and games played, but that's likely a result of the increase in performance of home runs and RBIs, things like that. But these first three would be things we think probably aren't going to be impacted, and we would call that kind of a counterfactual, right? We should see no effect here, and sure enough, they don't find one. And then this was kind of from the other one, right? We already looked at the home runs variable that was kind of just coming from the other table. They then also try to do this counterfactual where they said, well, look, there was other players that are kind of known to maybe have used, or there was suspicions that they used steroids. And so even people like Mark McGwire, who we now know was using steroids, right? They didn't have a reputation for introducing other players to it. So they ran a regression similar to this one, where instead of playing with and after playing with Canseco, they just changed it to, in this case, Rafael Palmeiro. And then they ran another regression where they changed that to, did they currently playing with or after they played with Jason Giambi, right? And then et cetera. They ran a different regression for each one of these players. And then they showed you the coefficient on that after playing with that player variable. Now, what's interesting is we had those positive effects that we saw from playing with Canseco on home runs, strikeouts, and RBIs, and it looks like at bats as well. Every other player here, notice nothing significant. And when it is, it's actually negative, right? So this actually meant that even for some of these known users, like, where did he go? McGwire, right? There's no effect, right? Or Rafael Palmeiro, but actually it was a negative effect. So maybe they were giving advice not to do it or something like that, right? Or they saw a player who wasn't using steroids and thought, well, I can mimic that. So it was less likely that they actually used steroids, and subsequently we actually saw their performance go down. So, you know, this is another good counterfactual where it's like, well, it's not just random, right? Every other player that we're looking at here, even ones that we know were using steroids, there's no positive effect on players' performance after they first start playing with that player. The only one where it exists is for Jose Canseco, the one who had kind of this reputation. So this is a pretty interesting result. Once again, you know, it just shows kind of what we can do with regression, right? What we can do with regression analysis. I think, yeah, I won't waste time on that. It's basically kind of similar findings. They do something a little bit different where they separate it out by years. And they find that maybe in later years when there started to be some enforcement by Major League Baseball, well, then the effect kind of goes away, right? And that players were less likely to use, but that kind of makes sense. There's now policies that make it less of an incentive to actually use steroids, okay? So the other one that I wanted to take a look at, and this was like relatively new, I forget, I want to say it was 2018 or 19 it was published. So there was this paper and they had Taiwanese like high school or middle school age students, and they were looking at their swimming performance. Okay? So they have this idea of, well, look, it's really hard to estimate peer effects. So for instance, you don't want to think about peer effects in this way. If I'm on a basketball team and the players that I'm playing with are better, does my performance also go up? Well, it's hard to disentangle between, did I gain something in terms of my performance because I'm practicing these players right there, I'm able to kind of learn from them, or is it, well, we're playing in the same game, so if they perform better, maybe it draws the defense away from me, I'm able to get an easier basket. Well, that's not really peer effects. When you think about peer effects, it's something that it's independent of what, like, their behaviors aren't going to have any impact on your performance, in the sense of they're not like interrelated. So in team sports, we can't really estimate peer effects very well, because part of the game is that us working together will lead to both of us to have higher performance. The idea of a peer effect is something like it happened prior to the game. Just being around better players, my performance increases. So it's really hard to do this within team sports, but you can do it with individual performances, which swimming, right? We don't have any relays or anything in this data. This is just individual kind of, 50-meter backstroke or whatever the race was. So here what they did was they looked at the time or the performance of the swimmer, and then they had this variable which measured, well, what was the average time or the average performance of everyone else on their team, right? So if the average time of everyone else on their team goes up, do we see that their actual performance goes up as well? Or do we see a positive coefficient associated with that average time of all of my teammates? And here they were a little bit concerned with, if they were in the same race, that might have an effect. And so they didn't just use the average time in this year, but from 1 year prior. That way it was results where the player wasn't in those races. Okay? They also do something with the standard deviation. We're not going to kind of talk about that. It's a little bit outside the scope of this class, but we can kind of think about this average time measuring the quality of the teammates. Okay. So average time was the competitor. So we see if the average time goes up, right? And here, I think what they ended up doing was flipping it so that it made more sense to discuss the results. So usually if average time got higher, that's actually worse performance, right? And so the way I'll talk about it when I'm saying an increase in the average time, it's actually like if I'm swimming against, or if I'm on a team with worse swimmers, my time would actually also go up. So I would be worse. So it's a little bit weird because we're usually thinking about, well, if they perform better, I do as well. Here, time being longer or larger is actually a bad thing if it's a race, right? So here, if the average time of the teammates goes up, the players or the swimmers' performance also went up, right? So this is like a negative peer effect, right? When my teammates are worse, I also perform worse, right? And they find that in kind of some different models that are, once again, everything that we do in this class is really what is called like OLS, right? And you can kind of add in some different models. And some of the models, they found that this effect isn't significant, but they always find kind of that it's positive, okay? So this is some other kind of newer, stronger evidence that even in grade school, we see kind of this peer effect going on. And really the only way we can estimate it is when we look at individual performance sports. So that's all I had in the slides, but I did have one more paper that I put up there today that I wanted to look at, which is this peer effect in soccer one. So this is a variant. I just came across this paper like the last week or so, last couple of weeks. And it is a very interesting way of approaching an issue. So they start out with a question of how can we estimate peer effects within team sports, right? We know this issue exists, that when players are performing together, right, we can't like disentangle the performance. And so what they did was use a video game. So they used the FIFA video game and they ran simulations, right? So they ran simulations of every season, and I forget how many times they did it for each game, but they used those average rating of the player. They used that as the measure of player performance, and then also for the teammates' performance, right? So it wasn't actual performance measures, right? It was based off of their rating in the video game and then these simulated performances. So I'll scroll down here and kind of see what they found. There's a chart, there we go. So they had that kind of performance measure of the player. That was just going to be their rating in this video game. And then kind of the team here, or sorry, I think it was actually X here, was kind of their teammates average, or sorry, their teammates average rating the year before, right? That way they're not kind of looking at current years where they have kind of can't disentangle these effects, right? So we'll scroll down. I forget what this was related to, but here's their results, right? So once again, kind of OLS, this is going to be kind of how we generally run. I've shown you how to run regressions, and I've tried to always use a lot of papers that have just an OLS approach. They also did kind of, like I mentioned in earlier papers today, where they included individual fixed effects, right? So an indicator for every single player in this data set. So what they found is that when the average rating of the teammates in this video game was higher the year before, that player's rating the following year was actually higher as well, right? And so it's not, you know, this is an interesting paper. It's not void of the issue that, well, yeah, these ratings in the video game are still based off of the performance in real life. So we haven't truly disentangled those effects, but, you know, they have, you know, the way they set these ratings is they've probably looked at player performance data, and they probably run regressions to estimate kind of what the predicted measure would be, right? Or predicted rating would be for that player. So people have tried to, you know, parse out these effects when they're giving these ratings, but it's not perfect, right? So it's still pretty interesting that you find when players have, on average, higher performing teammates, that in the subsequent year, they're given a higher rating in the video game, which should indicate they were performing at a higher level as well, right? That's, you know, why else would they have been rated higher in the video game unless there's some kind of individual bias going on, right? So kind of, I think, an interesting result there. There was nothing else that was overly interesting here. I mean, some of this stuff makes sense, right? When your height is tall, or if you get a little bit taller here, you actually saw that the performance measures, they were rated a little bit lower. You know, in a sport like soccer, it's always better to have kind of a lower center of gravity. And so that's typically kind of a relationship that we see. So a lot of the other control variables here line up with a lot of what other people have done, even though this is just kind of simulated video game data. Yeah, so I don't know. I thought it was kind of an interesting paper that was very, like I said, very, very new. It was published in the last year, where they don't just use the actual performance data that exists out there, but they're using things like video game data. You know, a lot of papers I've seen in marketing specifically, they'll look at, instead of using player performance as a measure of fan favorites, like of quality or superstardom, they'll use things like jersey sales as a good measure, because there people are voting with their dollars, or all-star votes from the public. And so you start to get a little bit creative with, we don't just have to use this data that exists from the play, but some of these other things that are kind of revolving around that sports world or realm as well. Okay. So really didn't have a whole lot today, and this day was gonna be a little bit shorter. But if you guys have questions specific to kind of your projects, or maybe just in general, you know, I can walk through things in Excel. I can walk around and kind of help you with that if you brought kind of your data. Maybe it'll be a little bit chaotic, but maybe it's some group stuff too. We've got a lot of people here. I can only help one or two people at a time, but ask the people around you kind of what they're doing theirs. If you have any questions, you know, maybe you guys have similar questions. So talk with each other, or raise your hand. I can come around and kind of start helping people with stuff. Okay. Yeah.
I had a question about the final exam review. Are we going to have a final exam review?
Yep. So that'll be next class. I think you came a little bit late. Also, our exam's next Thursday at noon. So we've got a couple days next week that if you want to come in and kind of get some additional help, that's possible. But yeah, I'll be going through some of those practice problems on Thursday. Yep. Any other questions not related to projects? Good. Okay. All right. So I'm going to stop this because no one else